Hello everyone! Thank you for clicking on this video. I'm Marianne and now I will try to explain the basics of matrix. I hope you'll enjoy. First of all, what is matrices? So matrices is the plural form of matrix, which can be defined as a rectangular array of numbers, symbols, or expressions arranged in rows and columns. Row is the data spread horizontally, while column is the data spread vertically. Now, we read the dimension of matrices by row, then column. So for example, we have this first matrix. It has 3 rows and 3 columns. We say it is 3 by 3. Let's see another example. It has 4 rows and 2 columns, so 4 by 2. And the third, we have 1 row and 3 columns, so it is 1 by 3. Now on to addition and subtraction. In addition and subtraction, we must have the same dimension. So for example, we have these 2 matrices that are to be added. It can only happen if they have the same dimension, in this case 3 by 3. The result will have the same dimension as well. Again, 3 by 3. All we have to do is just add the numbers according to their positions. So for example, we take the number which is in the top left, which is 6, and we add it by 4, which results to 10. Now we do the same thing to the whole matrix to get the sum. The same thing applies to subtraction. The matrices has to have the same dimension. So again, we subtract 6 by 4, which results in 2, and again apply the same thing to the whole matrix. Now this is where it gets a little bit tricky. For multiplication, we have to make sure that the number of columns on the left matrix has to be the same with the number of rows in the right matrix. For example, we have a 3 by 1 matrix multiplied by a 1 by 2 matrix. So these two numbers have to be the same. The product will be the numbers left, which is 3 by 2. Now, the key to multiplication of matrices is left equals rows and right equals columns. So what does this mean? Basically means we only see the rows on the left matrix while we only see columns on the right matrix. So as you can see, we have 3 rows on the left matrix and 2 columns in the right matrix. Now the product corresponds to that as well. So we just have to multiply the numbers. For instance, in row 1, column 1, we will multiply the number in row 1, which is 6, and the number in column 1, which is 8. On row 2, column 1, we multiply 3 by 8. Now we do the same thing to the whole matrix until we get the final product. Finding the determinant of a 2 by 2 matrix is fairly simple. For instance, we have the matrix A. The formula to find the determinant is AD subtracted by BC. Let's see an example. We have the matrix A. The determinant is AD subtracted by BC. So we have 2 times 7 subtracted by 3 times 1, which equals to 14 subtracted by 3, which is 11. Now inverse. Inverse means opposite or contrary in position, direction, order, or effect. A practical example. The inverse of x equals to 1 over x, which is also equal to x to the power of negative 1. Now, the inverse of a matrix is also the matrix to the power of negative 1. Now, how do we solve this? The inverse of this matrix equals to 1 over the determinant of A multiplied with the matrix with slight changes. We switch the positions of A and D, and we add negative to B and C. So there we have it. Let's try to do a question. So to find the inverse of matrix A is 1 over the determinant of A, which is 4 times 2 subtracted by 3 times -1 times by the matrix, where we will trade places 4 with 2 and add negative to 3 and -1. So we will get 1 over 8 added by 3, which is 1 over 11. Now all we have to do is multiply 1 over 11 to each numbers, which is 2, -3, 1, and 4. And then we get the inverse of matrix A. So that is all for the video. I hope you enjoyed it. Thank you and see you next time.